Okay, so we're coming back to this sort and array, and the way that I'm going to try to implement it is with quicksort. So right now I'm trying to practice quicksort, even though I know that this problem has specific test cases built into it to make quicksort fail. So the idea is to get quicksort working, not to actually pass this problem, if that makes sense. Okay, so the idea with quicksort is I'm trying to take all of the elements of the array, I'm trying to find a randomized pivot, and then from that randomized pivot I am trying to get all of the numbers less than the pivot on the left side and all of the numbers greater than the pivot on the right side. Okay, so that's what I'm going to be trying to do. So I know that I'll need to let's see, recursively go in and do it on each subarray. So I'll need to like solve or sort, maybe sort, maybe organize, I'll say. Organize from start to stop, okay? And then this is the function that is going to be responsible for actually once I give it a pivot, okay, then it will put all of the smaller numbers on the left-hand side, all of the bigger numbers on the right-hand side, and then put the pivot in its correct location. So that's where this one is going to be, right? And then I need the actual recursive function, so we'll call this one solve. I don't know what parameters it's going to take in yet, but we're going to have a base case which would be, the base case is going to be if we only have an element of 1, right? If start is equal to stop, okay, then we return. And are we trying to return any actual numbers? No, not yet. Okay. And then we'll solve on 0 to length of nums. Okay. So if we are not at the same pointer index, we're going to be going like this, and then like this, and then here, okay? And we'll do that recursively for every single element. And it stops when it hits its base of that singular element. But if it's not that case, if we even have 2, I need to send that to the organize, right? Yeah, and then I'll also need to know the pivot location. So pivot index is going to be equal to organize, right? And start, stop, like this, okay? So I need to eventually return something here. Return pivot index, like this, okay? So once I have the pivot index, I can recursively call myself, and I'm noticing I have start and stop here, so okay, let's put those in here. Start, stop, like that. So then I'll need to be able to recursively call myself, solve on the left side of the array and the right side of the array. So that's going to be from my own start to the pivot index, but the pivot index is in its rightful place. So I don't need to do that one. I need to do 1 over, like that. Likewise, I can solve on pivot index +1 to stop. Yeah. And I'm noticing that this stop, I'm making it as inclusive, so I need a -1 right there. Okay. So I think this is the basic structure, and we have tried to do this problem in the past, obviously. And so this part is, okay, whatever, that's fine. The more interesting question is this one right here, like how do we do this one? Okay, so that's what I'm trying to really practice today. So, great. I have my organize. I want to find a pivot, right? Pivot, I'll just call it location, is going to be equal to, what was it, randint, something like this. And then within here, I pass in the parameters from start to stop. I don't know if this is inclusive or not. Something to be aware of, but it's not part of my core mission right now. So this might be wrong. Is stop inclusive? Okay. But anyways, I'm going to randomize it. So now I have the pivot location. Pivot is going to be equal to nums indexed at this pivot location here. Okay, awesome. So now I have my pivot location. I think the way that we do this is we take the pivot location, we swap it with the 1th element, or the 0th element, okay, and then I do all of my sorting, and then I say that I know where this 0th element is, and I know that this element here is less than the pivot, so I'm allowed to swap them again. So I think I go something like this. Nums of start, okay, there we go. Nums of pivot location no, is equal to, and then the opposite of these. Okay, pivot location and nums of start. Okay, so we swapped them. Now what we should be able to do is I want to use fast and slow pointers, and I think that there's actually 2 ways of solving this question. One is with like 2 pointers that go in like this. The other one is with fast and slow pointers. So let's first do fast and slow. Slow is equal to start, okay? Like this. Now, what does my fast mean and what does my slow mean? So my slow is going to be pointing towards, it's going to say every element behind it is definitely less than my pivot, because it's not going to move unless it finds an element that is smaller than the pivot. If it's a number bigger than the pivot, fast is going to start coming out here and looking for the next element that conforms, so the next smaller element. And then if they find one, they swap, okay? And now my slow can move over by 1. Slow moves over by 1, and now think about it, I just put a smaller one here, and then I move over by 1. So it means that everything behind it is still smaller. Okay. Now my fast is coming out here and exploring. And all of these, it's already found, are bigger than the pivot, right? So if the fast reaches the end and goes off, we know that we've gotten to the right location. So while fast is less than nums. Okay. Nope, 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 stop. Not stop, but I mean then our stop. Okay. Alright. Now, what do we want to do here? So the thing is, we can either find an element that conforms, right? If we find an element that conforms, we need to swap it. Okay. So if nums of slow okay, so this I'm looking for non-conformance right here. So if nums of slow is larger than my pivot, right? This is a non-conformance condition. Okay? If this is the case, then what do I want to do? I found one that doesn't conform. I want fast to start coming out here. Okay. Until it finds one. But what if the case that it is conforming? Let's say it is conforming. I want both of them to move over by 1. So let me say maybe conforming condition would be the slow. It's actually less than the pivot. So that means we're good. So slow can move over by 1. Plus equals 1. And fast can also move over by 1. No, because I need some way of guaranteeing that fast is going to be stopping at a I I need some way to guarantee that fast is going to be stopping at an actual location which is bigger, right? Or smaller. What if I look at this from the perspective of the fast? So if I move my fast... What if I... Yeah, let's come think about this. What if I look at it from the perspective of fast? And if I move fast over by 1, hold on. If I... If I assume that I always move fast plus equals 1, okay? If I move fast over by 1 each time, I can always perform a swap. And fast is going to be either greater or larger, right? If we're here, and it is smaller than the pivot, I swap with myself, which is fine. Here, if fast is smaller than the pivot, I swap with myself. Here, if fast is not smaller than the pivot, right, it's bigger, I move over. Move my fast over and not my slow. Okay. So now, if this one I need, if my fast is, if I found a one which is smaller, right? I say, hey, I want to swap this with the slow one. Then we swap, okay, so nums of slow, nums of fast is equal to nums of fast, nums of slow, like this. And then we can move slow over by 1 in this case because we know that, okay, I just put a number which is either we're pointing at the same location here, right? We're pointing at the same location, and I just found something which is smaller than the pivot, which conforms. Okay. Oh, I'm also noticing that this is start plus 1 because this would not be length of stop. Okay. So now my slow is constantly is only moving when I found an element which it's a little bit weird to think about because it's kind of inversion of things, where it's the fast that is controlling things, right? And the fast will always move over by 1. Okay? And the fast is just saying, okay, I either swap you or I don't swap you. If you are smaller, I swap you. And then we can both move forward because we know that that element was sorted. Otherwise, I'm just going to keep moving forward until I find a smaller element. I keep going. There, I found a smaller element. Okay, swap it. Bing. Now I know that I have a bigger element here. Okay, great. Or actually, I don't even know that I have a bigger element right there, right? Because it might be the case that it's right up to it. Same, but okay, great. My job is done. Moving here. Okay, it's a weird thing. I think that this might be somewhat, I don't know about the syntax. Okay, yeah, it's fine. Alright, let's see about this. So this is from a couple days ago. Let's see if we did it any better. Oh, I do want to see one thing. Same question, different tab. Is this actually going to be... can we get rid of this? Good. Anyways. So, is this actually going to be... Stop. Let's take the case where there's two elements. Okay. If there's two elements, I take a pivot. Let's say I put this pivot. Oh, I didn't actually put the... Hold on, there's something else I need to do right here. But I put the pivot at the first location, okay? And then I put both of my pointers to the 0th location, okay? And then they're gonna run, and either I swap it with itself, and then move to the next one. That's if it's smaller than the pivot, right? Actually, wait, no, I come here. And now I know that the pivot is... I don't have any information on the 0th element. Because I moved +1, right? Okay. So in that case, am I actually... If I moved over by 1... this, right? Because I need to put that 0th element back, but... Let's see where it says that I did things wrong. Okay, yeah, that actually, yeah, I just swapped it. Right, we do need it inclusive, okay. Because stop is inclusive, we need to count this element. But here I don't seem to actually be sorting anything. Let me just get this. I'm just going to copy and paste this one. Random.randint. Okay, whatever. There. Does it run at least? Pivot index. Oh, right. Nums, or no, it will be slow. -1. Why is that one having an issue? Oh, we'll figure that out later. Yeah, figure it out right now, I guess. So here, but I'm not understanding why that would be. There's two questions that I'm having. If we have two indexes here, right? So it's saying if start is greater than or equal to, kind of like this, I think. But why do I need that greater than? Oh, and we get wrong answers anyways. And then we actually, oh, we don't do it in place. Okay, hold on. Are you going to be happy now? Okay, there we go. Okay, cool. So we got the algorithm correct, I think, but I have multiple things that I'm confused about. First one is, what if we only have two elements that come into my organize? So I'm going to ask this. It is now working, but I want to visualize what happens when we have only two elements which are passed in to the organize. Maybe can you show this process use with F and S inside of the boxes with numbers in them. ASCII and how they change. something like this, okay? The other one is, can you do the same thing for why I need to have the condition with the greater than sign. Okay. Let's get this going. If my finger can get inside of it, never mind. Not gonna have it right now. This is a perfect way to debug. Visualization clears up off by 1 errors immediately. Let's look at 2 elements and see why the greater than is the safety net that prevents your code from crashing. Okay. Visualize organize with 2 elements. So 10 and 5 is here. I should have said to do both when the larger number is in the front and the larger number is in the back. I forgot to say do it in 2 cases. So we will come here and then indexes 0. Okay, that's just indices. Then the array, okay, and then pivot at start, okay? Set up the pointers. Fast and slow are going to be here, right? It's equal to stop, so we're going to run. It says, is fast smaller than the pivot? No. Slow does not move. Fast increments to 2. Then it's out of the bounds, okay? So then we swap the 0th one with the one behind it, okay? The greater than, or the greater than sign is there because the pivot, there we go. I need some caffeine to try to focus on this. So the greater than sign is there because the pivot can land at the very edge of the range. Okay. Okay, that makes sense, right? And in that case, what's going to be the problem? Let's come here. Let's say that my pivot comes and it's the 0th index. Okay, that's possible, right? Solve of 0 minus 1. Oh, I see. Wait, then how did that change it there? Because it... Well, then that just brings up a new question, because if this is at this comes back and the pivot is at the 0th location. Okay, well that brings up another question I didn't even think about. When the pivot lands on at an edge, okay. Solve 0, 1, okay. Returns pivot 0, okay? Now we call the two halves. Yes, the questionary. If your condition is if start is equal to stop, return. Wait, hold on. I'm not calling. Oh, I'm on solve. This is not organized. Okay, because I'm not going up there. Okay, maybe I need to take a little bit more of this. Okay. Then I come back up here and I have negative. And that's why. So stop is going to be negative. Start is going to be positive. Okay, that makes sense actually. Okay, I didn't think about that. So now I'm going to try organize number 2. So this will not pass because they purposefully make it where this question doesn't pass. But I'm going to try def and then organize. Two, okay, and we're going to have something very similar. But I want to use the different technique. So we're going to have start and stop here, okay? Now I want them to go like this. So while start is less than stop. If they're the same one, then it's already organized, right? And when we come here, it's going to get to its location there. There are 2 here. And I'm either going to swap them and then move and they cross, okay? Or they're already there and we're good, and then okay. Well, here, okay. Oh, actually, it's not going to be start and stop. It's going to be while left is equal to start, right is equal to stop, okay? And now, while left is less than right, okay? Now I want to bring them into each other, right? So I want to come in here and I want to say, if I found a so I'm going to keep moving my slow over until I find a non-conforming, right? While this case is still true, and nums of left is smaller than pivot, and let me just try to do this by myself. If I say like pivot location is equal to, what was it, random dot rand int. Oh, I can look down there. Rand int, yeah, and then start stop. Okay. And then pivot is equal to nums at pivot location, this, then set the pivot location equal to 0. I'm just going to copy this. Okay. So in this case, nums of left is less than pivot. So that means we want to keep moving it over, right? Left plus equals 1. And then it's going to stop when either we get outside the bounds of the array, or whenever we hit a location where we say, oh, this one is bigger, so we need a swap. And now I'm going to do the same thing for my fast. Okay, so while same condition, because these two are and nums of right well, nums of right is greater than my pivot. Okay, I want to keep moving my right over. Okay. And so they're going to either I have reached the case where we got outside the bounds of the array, but what I'm thinking right now is this going to be equal to, because right is stop and this is inclusive. Okay. So either we've gone outside the bounds. If we are outside the bounds of the array, here, not equal, then what I want to do is return no, I want to break. Okay. Otherwise, I want to come in here and I want to say I want to swap them. Okay, so let's it's not going to be there. Okay, so nums of left nums of right is going to be equal to nums of right, nums of left. Okay. Swap them and then move. Now I say that, oh, they are both in conformance. I can move both of them now. So left plus equals 1. Right minus equals 1. Kind of like this. Okay? And then at the very end, I can say that my left pointer is always pointing to the one that is less than. I'm realizing this left here is going to have to be start plus 1 because we put this at the start. Okay. So now what I want to do is I want to do start nums at start, nums at, and then what is this index going to be? Left, right? And left is guaranteed to be one above, so I can index it here. Not return break, it's just return, or just break. And then I want to return left minus 1. Okay, where is my error now? But this is going to be for the spot where it is this is going to be for the spot where it is so if they're equal to each other, if they're equal, then they're still in the bounds. That doesn't. Okay. Pattern to the horse. The left and right pattern in organized 2. It's great. More efficient, but it's notoriously easy to get stuck in an infinite loop if the conditions aren't perfect. Okay. So look at your while condition in organized 2. While left is greater than or equal to right. There. This loop will only run if the left pointer starts ahead of the right pointer. Since you initialized this and right is equal to stop, left is almost always less than right. It's not the one. Okay, I'm just going to close that. It must be... So left is, yeah. Okay, that makes sense, but we're still gonna get, I don't, yeah, that part was just oops. This part, I want to find the fundamental misunderstanding that I'm having in the horse pattern. The moment left and right cross each other, the partition is done. Okay, use ASCII. Okay, we have this, and the pivot is 10. Is move to start left at into, okay. Yeah. Until they find the wrong elements. Is less than, so moves over. It's not greater than 10, or less than 10, so it stops here. Okay. Eventually, they will move the last element. Okay. So what? I see that this is different, but why use right instead of left -1? The loop finishes right and left have crossed. Right ends up on the smaller side, left ends up on the larger side since we stashed pivot. I have no idea. So I've failed this problem about 5 or 6 times so far. I really hate all of this. Okay. What did I do? Notice the use of right as the return value. On the smaller side. Start with it in the middle. But right is pointed to this 15. Isn't it? But isn't right pointed to 15? That is not the pivot. Okay. Rules of the road for horse partitioning. This is why the logic feels so slippery. You have to remember these two rules. The left pointer is searching for a number that is too big, needs to go to the right. It eventually lands on something which is greater than or equal to the pivot. The right pointer is searching for a number that is too small. It eventually lands on something which is less than the pivot, okay? When they cross, everything to the left of R is guaranteed to be less than pivot. Okay? Everything to the right is guaranteed to be larger than the pivot, okay? Because pivot is stashed at the start. The left, it must be swapped with right because right is the boundary of the small zone, okay? Okay. So in the final state, L was pointing at 15. You swapped it with... So I need to... Okay, I'm trying to figure out how I can move forward with this problem because it's like... I've been trying to do it for a long time. Technically, I was able to get one of them, right? I was able to get this one, but I keep failing and not being able to understand how to do these array manipulations. I don't know if it's more practice or if it's like an IQ problem. If it's just like I'm not conceptualizing it. I'm not sure. So I think what I'm going to do now is I will try to maybe watch some more videos to... I have the name for it now, like whatever the... horse, another one. So Lomuto and horse, so I can look up these two and try to visualize it and see if I can understand it better in that way. So I think that's how I'm going to move forward right now. And then, yeah, I need to continue with more of these awesome array manipulations, because that's exactly the things that you don't want to do is exactly what you need to do, because that means that that's where you have the problem. So I don't want to do any more array manipulations, so that means I'm going to be doing more array and manipulations. So anyways, thank you guys for watching this video. If you liked it, subscribe. I would love to have you around on the journey. We're going to keep on going, keep on improving, hopefully. And yeah, so thanks for watching. My name is Timothy Lee Grant, and I will see you guys in the next video. Alright.